Welcome to a webcast produced by the Learning Enhancement team based in the Dean of Students office at the University of East Anglia. This webcast is part of the Steps into Algebra series and concerns rearranging equations. This guide offers an introduction to the essential mathematical skill of rearranging equations. It details a neat flowchart method to help determine which order to carry out the rearrangement and compares this to another well-known method. The technique will then be used to solve and transpose equations. Introduction. One of the most common skills required in algebra and science is the ability to rearrange an equation. In mathematics, you may be required to solve a problem to find the value of a variable which satisfies given conditions. For example, solve 6x minus 4 all divided by 3 equals 12. This question is asking you to find the value of x which makes the mathematics of the left-hand side of the equal sign equal to 12. In science, you are often asked to transpose a given equation so that it is written in terms of a given variable. For example, write a equals pi r squared in terms of r. Here you are being asked to rewrite the equation in the form of r equals some mathematics. Both these questions require the skill of rearranging. Mathematical inverses. It is crucial to understand mathematical procedures called operations and their inverses if you are to understand how to rearrange an equation. A mathematical inverse undoes an operation. For example, let's consider the simple mathematical operation of adding. It should be obvious that to undo adding, you must subtract. It is common to think that subtraction is the opposite of addition. However, you should avoid thinking of opposites and think of subtraction as being the inverse of addition. The table below lists some common mathematical operations and their inverses which you should become familiar with. The inverse of the operation of adding is subtracting. The inverse of the operation of subtracting is adding. The inverse of the operation of multiplying is dividing. The inverse of dividing is multiplying. An interesting mathematical operation is the reciprocal, which turns a fraction upside down. The inverse of reciprocal is reciprocal, i.e. turn upside down. Another useful operation is multiplying by minus 1. Multiplying by minus 1 introduces a minus sign into your mathematics, which is very useful. The inverse of multiplying by minus 1 is multiplying by minus 1. Note that multiplying by minus 1 is its own inverse. This is useful. You may expect it to be divide by minus 1, and in fact multiplying by minus 1 is identical to dividing by minus 1. The inverse of the operation of squaring is square rooting, and the inverse of square rooting is squaring. There we go. Flowchart method. Many students remember being told at school that to rearrange equations you must do the same thing to both sides. This is certainly true, and eventually this is the method that should be employed. However, when learning to rearrange an equation, sometimes realizing what to actually do to both sides is a problem. If you know how an equation is built, then this offers a strategy to undo what has been done and carry out the rearrangement. The flowchart method can help you see how equations are built and hence rearranged. It uses the concept of a target, which is the variable which you are rearranging for. Here's an example. As a start, let's consider one of the questions above. Solve 6x minus 4 all over 3 equals 12. The aim of the flowchart method is to build the side of the equation where the variable you are considering lies. Here you are looking for the appropriate value of x, and so x is your target. You are looking to build the mathematics which contains x. In this case, the left hand side, 6x minus 4 all divided by 3. Of course, you have to start somewhere, and you start with your target x. Then, using mathematical operations one at a time, you must construct the relevant mathematics. At each stage, ask yourself, what do I do next? And try to make sure that your logical reasoning is correct. Remember, you can only use one operation at a time, and you must construct the piece of mathematics exactly. You have 3 operations in this expression: multiply by 6, subtract 4, and divide by 3. You must multiply x by 6 first, as the 4 is subtracted from 6x to make 6x minus 4. You must then divide by 3, as the 6x minus 4 is all divided by 3. This reasoning is best illustrated as a flowchart. Begin with your target x in a box. Here, first thing to do is to multiply x by 6, which is shown as an arrow with the operation above it. Multiplying x by 6 gives 6x, which goes in the next box. Then subtract 4, shown as an arrow with the operation above it, to give 6x minus 4 in the next box. Finally, divide by 3 to give the required expression. Now for the clever bit. You know that the expression you have built is equal to 12. Underneath your flowchart, if you start with 12 and go back the other way, doing the inverse of the operations indicated above, you will solve the problem. From the starting point of 12, multiply by 3, because multiplying is the inverse of dividing. 12 times 3 is 36. Then add 4, as adding is the inverse of subtracting. 36 add 4 is 40. Finally, divide by 6. To find that, x is 20 over 3. This can be checked by substituting 20 over 3 for x in the question and verifying that the result is 12. It is important to line your boxes up correctly. If you do, the final box you draw is the solution. The lower flowchart is identical to the technique of doing the same thing to both sides. Example. Write a equals pi r squared in terms of r. This time, r is your target. Firstly, r is squared to give r squared. And then r squared is multiplied by pi to give pi r squared. This is equal to a. So returning, doing the inverse, you must first divide by pi. To give a divided by pi, and then take the square root. This tells you that r equals the square root of a divided by pi. Reciprocal.